For centuries, mariners of old looked to the sky for navigation. Using basic tools and accumulated knowledge, they sailed around the world. Then, as humans took to the skies and then began to fly inside of clouds, where they couldn't see the ground or the sky, ground-based electronic systems such as ADF, VOR, and ILS were developed and endure today. In fact, almost all the current airways and instrument approaches are based on these systems. Well, there's a new kid on the block who, like the ancient mariners, takes his cues from the skies instead of the earth. When this new kid first got here, he still had training wheels, restricted to VFR use only. But now he's all grown up, approved and readily available for IFR. So with that in mind, let's take a look at how the newcomer to the world of IFR navigation works. We're talking about the Global Positioning System, or GPS, a Defense Department-funded constellation of 21 orbiting satellites and 3 orbital spares. They're nearly 11,000 nautical miles above the Earth and complete an orbit about every 12 hours. Because orbits like that are predictable, we always know where they are. Each satellite sends a message telling where it is and when it sent the message. A thousandth of a second later, it sends another message updating its position and the time. So, how does it work? Well, the GPS uses time to measure distance. Your GPS receiver notes the time it received the satellite signal. Since the satellite told the receiver when it sent the signal, the receiver's computer does a quick subtraction and figures out how long it took for the signal to arrive. So now the GPS's computer whips out its electronic E6B and says, let me see now. Radio waves travel at 186,300 miles per second, and that signal took 60 thousandths of a second to get here, so the satellite was 11,178 miles away. Just your basic plain old time, speed, distance problem. Your Skyhawk's GPS can do this with several satellites at the same time. If it can find out how far it is from any 4 satellites simultaneously, it knows where it, your Skyhawk, and you are. And in theory, that's all there is to it. Although there's a little glitch getting all those clocks ticking on the same time. Now, the clocks in the satellites are accurate to 1 billionth of a second. Clocks like that went for $100 grand a piece in 1986 dollars. So the one in your Skyhawk's GPS isn't quite that good. But your GPS's computer knows all those distances should end up in a single point. It performs some mathematical mumbo-jumbo, figures out what its clock's error must be, and everything is hunky-dory. And that's why there's a delay in getting information when you first fire up your GPS. But enough computer talk. Let's look at the goods. It's important to note that the GPS receiver only takes up a portion of the box, and all that really does is say you are here. The rest of the goodies in the box are there to help you navigate from one place to another. You're probably already aware that there are several different makes and models of GPS units available for the IFR pilot. Each may differ significantly from any other with its buttons, knobs, and display formats. But despite these differences, many of the functions and capabilities are common to all IFR-approved units. You'll just need to know how to access them on your particular GPS. All IFR GPSs have a database for a particular area containing airports, VORs, NDBs, and intersections. You can select any of these as navigation waypoints by using the same names or identification you find on the charts. You literally have an electronic aeronautical library at your fingertips. The databases for most GPS units generally include frequencies, runway lengths, elevations, and services available, as well as the latitude and longitude of the waypoints. GPS also allows you to define your own waypoints, such as Lake Wolford in Southern California, locations you want to use that are not in the database. You store the appropriate positional data for these aptly named user waypoints, and then you call them up just like official waypoints, such as VORs or intersections. For example, if you regularly use an uncharted private airport, you could save its location in your GPS and use it as a waypoint. All this becomes exceptionally useful for you because not only does your GPS tell you where you are at any time, but you can tell it where you want to go, and it will solve all the navigation problems for you. Things like course and distance and time and much more. Now, the easiest thing you can do with a GPS is to tell it to take you directly from where you are to where you want to go. Just choose Direct To and enter the desired waypoint. Then the GPS computes the shortest route, meaning the Great Circle route, without regard for terrain and airspace. Your GPS may alert you to terrain and airspace problems, but the direct calculation will still be the shortest route. For a slightly more sophisticated operation, you can put several waypoints into a flight plan, and your GPS will take you to each waypoint in the order you select. Now, when you're navigating with a GPS, it's constantly calculating a bunch of different things. Things like the distance and magnetic bearing to the waypoint, your ground speed, your ETE, or estimated time en route, to the waypoint, your distance from your desired course, and your actual ground track. If you're on your desired course, then all you have to do is fly headings that keep your actual track matching your desired track. This guarantees that you'll fly the path you've chosen to that waypoint. To help you, you'll probably have two CDI presentations to choose from, one on the GPS display itself and the other on the VOR indicator connected to the GPS. Now, one of the handiest features you'll find on a GPS is the nearest function. There might come a time when you instantly need to know where the nearest airports are and their basic facilities. In this case, this is the first airport on the list of nearest airports, and it happens to be Oceanside. Well, a GPS can give you this information with the press of a button. And at those times, your GPS will be worth more to you than all the gold in Fort Knox. So, now you know how GPS works and what basic functions you can expect from one. Remember, though, that you'll need to know your particular GPS very well in order to use those functions, especially for IFR operations. Then, just like the mariners of old who looked to the stars for their guidance, you'll look to man-made stars for yours.